welcome everyone. I'm so excited you guys are here. We are going to be talking about test-driven development, and we're going to look at a CI/CD pipeline today. So let's just go ahead and get started. I'll just introduce myself real quick. My name is Liz. I'm a full-stack software engineering consultant, and so I've worked on several projects that have involved large Python engines, ETL pipelines, and extensive data analysis. I've worked with machine learning engineers and data scientists to build awesome products, and I believe in test-driven development to the extent that it's almost exclusively how I work when building applications. I'm passionate about learning new tools and technologies and using them for all the things they provide. Okay, so if you guys want to follow along in GitHub, you can scan this QR code and it'll give you a link to the project in GitHub. There's a README to help you run it, so anything that we talked about today, you guys will hopefully be able to follow all the steps, but if not, this is going to be really good practice, so we're going to see. So you can scan that QR code. There's also like links to connect with me or other references that I refer to during this talk. And then we'll also put this up at the end if you want to just grab it at the end. Okay, so what are we going to do today? Well, we're going to be doing a lot of things. We have a data set of movies, and we're going to build a simple movie recommendation engine. And that will be just kind of the first 10 minutes or so. And we'll be working primarily out of the Jupyter notebook while we build that. Once we finish the notebook, we'll know that we have something that works, and we'll know that we need how to prepare our data to be used in our engine. So then the rest of the time, we'll focus on productionalizing our data preparation scripts, which will involve the next 4 steps. We'll pull the data preparation step from our notebook and get them into a script. We'll pause on this for a bit while we talk about how we can make our script more modular, and we'll add tests. And we'll talk about why we do this. Then we'll have built these utility modules. We'll be packaging those all up. And then we'll be utilizing GitHub workflows to create a deployment pipeline. And then we'll be shipping and running our scripts in AWS Glue. So this morning we're going to see it all the way from the initial notebook to actually being able to run it, something that could run in AWS this morning. So why are we doing this? Well, I want to provide an example of applying TDD to large data transformations because it'll make testing like this feel more doable in the future if it's something that you want to do. When our code is less prone to bugs or regressions because of our tests, we'll save time and money in the future. And when we modularize our scripts, we'll enable future developers to build quickly, easily, and with confidence, which will improve their experience as we work together to build awesome products. Okay, and we're going to do all of that in 35 minutes, which is now probably 33. So let's go ahead and get started. So we'll start with our initial data analysis, which you guys have probably all done before. But what we're going to do is we're going to pull a data set of movies from Kaggle. So this data set that we're going to be using, I kind of modified it so I can prove some points here, but it has 40,000 movies with a genre, there's genres in one column. I'm just going to talk through really quick what you're going to see in the notebook because we're going to kind of move through it pretty fast. The genre column is a pipe-separated list of genres for the movies. What we're going to do is we're going to, in several different steps, we're going to transform that pipe-separated list of genres into just a string of genres as if they were the description of the movie. We're then going to use TF-IDF to create vector representations of those descriptions, and then we'll compare the movies to each other using cosine similarity so that we can find the movies with the most similar descriptions, so the movies most similar in content. So I'm actually going to pause this part, and we're just going to jump into the Jupyter notebook now, and it's going to take just 10 more seconds than you would hope it would to bring up the notebook. Okay, great. Okay, so, all right, so we'll go ahead and just, in here, it's going to take my computer a second to catch up. We'll run the first box, and then we'll look at our data, and then we'll look at its shape. And again, we'll just give it a second to kind of catch up here. But basically what we're going to be doing is we're going to be looking at this data frame. Okay, here it is. You can see when you first look at it that these genres are all different cased. And there could be leading and trailing spaces on that genres column. So we're gonna have to clean that up, and then we're also gonna wanna remove any rows that have this no genres listed category. This is sort of like a miscellaneous bucket, and if we were to group all those movies together and start recommending movies that way, users would get movies that probably are actually unrelated. Okay, so the first thing we're gonna do is we're gonna apply a function called lowercase and strip spaces to our genres column for every row. So that'll kind of clean up that genres row just a little bit. We're gonna write a function to do this, like I just mentioned, and we're just gonna do it in our notebook first, and then we'll go over into like our actual code and implement it there in like some sort of utility module that we can just import. So here I have defined our function, and I have like the notebook version here. And then before we actually use it, I'm gonna actually propose that we test it, and here's why. We're gonna be running this function on 40,000 rows of data, so we want to be sure that it's accurate. We're obviously going to inspect the result of running this function, but inspection doesn't always catch everything, so unit tests will fill in some of the gaps that inspection would leave. The other thing is that we are going, this function is really simple, so we could probably write it correctly the first time. But if this function is slightly more complicated, our unit test would give us faster feedback while we iterate towards the proper implementation of the function. And then finally, when we pull this function into a utility module and use that in a script, we'll know that these different pieces of our preparation script are well tested, and that will prevent regressions in the future. So I'm going to go ahead and define these 3 test cases. This is what we're going to use, and then I write this small test function here. You can see that this test function is just running our function that we're going to write on our input and asserting that it's equal to our expected output. So now I'm going to run our test before we actually implement the function, and we want to see that our tests actually fail first. A test that always passes is actually probably not a good test, because if these tests were to pass and this was the implementation of our function, we would know that we actually have a problem with our tests. So we want to see our tests fail, and we actually want to see our tests fail in the way we expect them to fail, so that we know that they're testing the right thing. So now that those are passing, I can just implement this function for us. Okay, and then we can go back down to our test boxes and run those again, and those all look good. So now we'll actually go ahead and go into our code, and we can look at the way the unit test looks for something like this. So on the right-hand side, I'm using this PyTest parameterized annotation, and you can see that it's basically doing the exact same thing we just saw in our notebook. This annotation is really useful if we have the same test logic, but we want to run it on like different scenarios, different inputs and outputs. And so that's what we're doing here. And so similarly, if we wanted to run these tests, I think I can just run this. And hopefully it won't take too long. We'll go ahead and see them fail. And we can also see why they're failing a little bit better here. We have our actual value, and then our expected value is different. So now we can go in here and we can just go here, and then we can say input lower, and then save that, and then we'll go back to our terminal and do run our tests again, and hopefully we'll see it passing. And we are, that's great. So now we'll go back into our notebook, we'll apply this function that we are pulling in with our imports, and then we'll go back down. That ran, okay, great. We'll go back down here, we'll sample that just to make sure it looks okay. We still have this no genres listed category in there, so we're gonna go ahead and remove that right here with this line. This giant box, the short version of what happens in here is that we realize that we have movies that are duplicated by title, but sometimes their genre lists are different. And so what this box will produce is a list of all the movies where that happens. We're gonna go ahead and just look at one of those examples. So you can see here, something like Aladdin, the genre column is almost exactly the same except for the very end. One has musical and one has fantasy. So we need to clean this up as well. We're going to do this in a few steps, but the end goal is that we have one Aladdin in our data frame or our data set. It has all the genres represented once, and they're separated by spaces. So first what I'm going to do is I'm just going to group those columns, and I'm going to put the genre strings into a list. This is running a little slow, so hopefully it'll catch up. Okay, so now that we have this list of genre strings, we're actually going to write another cleaning function, and we're going to test that one as well, called combined genres list. So you can see I'm doing something very similar here. I have two strings, crime drama horror and crime drama action, and I expect a set, that's what we're going to put it into a set first, of crime drama horror and action. And so if we go ahead and run this, you can say test combine, and what I'm running here is just the way from the command line if you want to run one test file at a time, and then it's going to filter on the name, so I just have to put a name of the test that will pick it up. Okay, cool, and then here I can go ahead and just implement this function. So I'll say all genres is just an empty set, and then for the genre string in input, we'll say genres equals genre string dot split on height, and then for genre in genres, we'll go ahead and we'll just add it. And then we can return it. And hopefully I didn't type it. If I go. With our tests. Okay. Great. Okay, so those worked, which is fantastic. So we're just going to run this function, and then we'll just keep moving here. I'm going to run the next couple boxes, get those going. So basically what we do then is we just join them with a space. When we put our, when we use the TF IDF vectorizer, we're going to need a list of all the words in our corpus, so all the possible genres. So we're going to have to get that string with this box. I think I just showed how many movies we have left. We have 35,000. We'll run the vectorizer, the cosine similarity matrix, and this last box really quick. Those are going to run for a little bit, and so I'm going to talk about this get similar movies function for a second. So the get similar movies function is going to take in a movie title, our cosine similarity matrix, our final data frame, and then we're asking for 20 movies. But this function does have a decent amount of logic in it, and so we are definitely going to want to also test this one as well. And so if I come over here, I'm going to say recommendation. I'll open a test for that on the right, and then on this side, I'm going to go ahead and open a couple test fixtures, similarity matrix fixture, and then on the bottom, or I'll just put it on the top, we'll do, what does this say? Movies fixture. Okay, cool. So what we're doing here is on lines 11 and 12, I'm importing these little fixture files. So if we had this like somewhat complicated logic and we were trying to figure out with those giant data sets if this is correct, that would take a really long time. It's going to take a long time for them to run, and it's more error prone. But if we make those two pieces of data smaller with these fixtures, we know exactly what to expect, and we can actually craft them so that they'll test the different pieces of logic in our code. So in this situation, this is like our mini similarity matrix. This is our data frame. If we're looking for the two most similar movies to Title 1, we should get back Title 3 and Title 4 in that order. And for Title 2, we would get Title 4 and Title 1 in that order. And so we can go ahead and in here we can run, let me just see if I have it in here. Yeah, we'll run this file, and we'll make sure that when we use those fixtures that everything is passing. It'll make just take a second, because it's also running something else. Okay, perfect. Just go back to our notebook and see if those things finish. They are still running. I'm just going to let them do their thing because my computer's struggling a little bit. But if you take, one thing to note here is that if we do, when we run this, and maybe we'll get to see it at the end. What we're gonna get is a bunch of kids' movies that have like action in them. So that's probably accurate, and we can see that there. I'm actually gonna terminate these boxes that can cause me any problems, and then we'll just close this, and then we can go back to our presentation. I'm also gonna kill this guy because it's working pretty hard. Yes, please. All right. So that was a lot. Okay. Go back here. That was a lot, but hopefully that stuff was like somewhat familiar to you guys. If not, again, that's all on GitHub, and so that you guys can go in and run all that if you want. And we're listening a sec to come back. Okay, it's coming back. Okay, great. We're here. Okay, so let's go ahead, and now we're going to look at our preparation script. So now that we have a notebook of code that works, we'll be moving on to extracting a data preparation script from our notebook. This script can be run on a schedule or on whatever other additional data that we get to clean it and prepare it for our engine. So if we just copy and paste the code from our notebook, we're going to get something that looks like this. This, of course, is a contrived and fairly simple example. If you spent time pulling code from notebooks into data preparation scripts, then you probably look at this code and think it looks pretty tame. You've probably seen a lot of scripts that look a lot more like this. So this could be okay as long as no one touches it. Or they're really careful when they do. But spoiler alert, someone is gonna have to touch it. If I'm the engineer coming in to modify a script like this, I find that I get the same sinking feeling I get when I'm upstairs wrapped up in something and my 5-year-old shouts up to me saying that he wants milk. But since I'm busy, he'll go ahead and pour it for himself. He may be able to pour it, and then I get to stay up here and continue on the chore or task that I so desperately need to finish. But the problem is, if he doesn't successfully lift the gallon jug up to eye level and pour the sticky liquid into the small sippy cup, I'll have a much larger mess to deal with. Similarly, we could proceed now without spending extra time to make sure that this script is manageable to edit and validate changes in the future. We could go on with our very busy days and get all the things done that we so desperately need to finish. But if we pause for a minute here, we may be able to prevent huge sticky messes that our future self would otherwise need to deal with. So why do we modularize this? Future engineers can understand it one piece at a time. Testing each module will prevent regressions in behavior, and the modules will be reliably reused. So that'll also save us time in the future if we can find a use for them. So here are the lines from our preparation script that fix the genres column. We can extract the part of our code that starts with the raw data frame pulled from our initial CSV and then produces a clean data frame ready for our scikit-learn libraries. Our function will look something like this. It can take in a data frame and produce a clean data frame. And inside are all the steps that we took to dedupe records, remove no genres listed rows, and produce a clean genre description for the movie. Okay, so this is what our test is going to look like. We'll be using fixtures again, and you see those on lines 5 and 6 here. These lines are where we import the test files that we build in order to test various scenarios. We've seen fixtures already, but it's important to think about how we build our fixtures in each case. In this case, this is our initial data fixture. It's just a mini representation of what our initial uncleaned input data looks like. And we use our Aladdin example that I just pulled directly from our data. And then we also used a scenario where the movie was missing its genre. The other rows are other scenarios we may have encountered. One situation where the no genres listed had leading and trailing spaces. Finally, we have one where there were 3 copies of the same movie, each with a different genre. When these rows go through our prepare genres function, we should see what we see here. So this is our expected output. We've dropped the movies without genres and combined properly the ones that do have them. So in our test, we have 2 assertions at the bottom, so we'll zoom into those. One of the assertions is that the number of rows of the actual data frame, the result of running our initial data through a function, is equal to the number of rows of our expected data frame. The other validates that the genre description of the rows in the actual data frame matches the genres of the expected data frame. This one is a little tricky because we don't actually care about the order the genres are in. We actually care about the content. But when we put those genres into a set and compare the two sets, we see that it can handle our data just fine. And now that we have fixtures, it's easy to build on the code we have in this prepare genres function. So let's say that we have another data set, and in that data set, there's a situation where the genres column can be empty. So we can see pretty quickly if that will work in our cleaning module. We can just add this last situation to our CSV. And when we run our test, this data would actually break in a lot of places, actually more than expected. But we can go through and update those broken pieces one at a time. So 2 other benefits of testing. First is that they provide context on what the code was intended to handle and how it was supposed to be used. This is incredibly helpful to developers coming into new code bases. Well-tested code that has readable test cases is easier for me to understand because I can read the test to understand what the developers hoped the code would do. And we can also refactor with confidence. So while we were going through the notebook, if you thought like, wow, she's taking a lot of separate steps to clean that genres column, I could probably do it in 1 line of code. You could do that now. You could make that refactor and you could run your tests to validate that everything is working the way you expect it to. Okay, so now we can look at our script again and substitute in our new functions for the code that they have inside of them. So we'll zoom in there. Here we call our prepare genres function that we just talked about, and then here we call another function we created that captures the full genre list, and that's just one I made separately. Okay, so most of what we leave in here is interactions with S3 and where we're just invoking library functions, and it looks better. And if we do this often, our script will remain a reasonable size of pieces that can be understood one at a time. Okay, great. So it's really good to pause on stuff like that. It's great that Jupyter Notebooks can give you easy feedback on your code the way that it does, but we don't necessarily want its feedback to replace good testing practices. And so by breaking the code into smaller pieces right away, we set up good patterns for the future that are scalable. Now that we have a great set of well-tested utility functions, let's make sure we package them up so that they can be deployed and used. Okay, so why are we going to do this next section? Well, when we push our prepare script to AWS Glue, it needs to have these modules available. Our prepare script relies on the modules that we just created. So we'll package our util module and then push it to S3 to make it available to our Glue job. So to package up our modules, we're going to be using a tool called Poetry. There's a number of options for packaging up modules like this, but I've really enjoyed using Poetry. It's a tool for both packaging and dependency management, but today we're mostly using it, focusing on like the packaging part of it. Okay, because we already have our module built out, we need to take our existing project and initialize it with Poetry. To do that, we can do something like run this command, this Poetry init command. And having this on GitHub and being able to look at the file structure is probably going to be helpful if you're trying to like walk through this, because our modules are sort of nested within our project. So if you're reading through the Poetry docs and it talks about the root of your project, here utils is going to act as like our root in terms of packaging. Okay, so after we run that init command, we'll now see a PyProject TOML file that you can see. Oh no, it's almost off the screen, but it's all the way down the bottom. A PyProject TOML file is a configuration file used in Python projects to specify various project settings, dependencies, and build tools. Okay, so if we look inside, this is what it looks like. It will have the name of your package, which is important because this is the name you'll use to import with, so make sure you use something that you like. And then some basic information about the package. So there's 2 things that I want to point out here. The first one of those is the Python version, and I call it out because it caused me pain, and I really don't want it to cause you pain. AWS Glue jobs only go up to Python 3.9, even though the latest Python version is 3.12. So you can set the Python version to something higher than 3.9, and it could actually work just fine on your machine, but it will not work in AWS, at least for the Python shell jobs. So you're going to want to pay attention to Python versions, and for AWS Glue Python shell jobs, set it to 3.9 or less. I think all those would do it, AWS Glue jobs, but I would need to confirm. Okay, the second one actually didn't cause me that much pain because it's explained in the docs, and I love docs, but this is where you would put dependencies that your module needs. Our prepare genres function is a part of the module that we just packaged, and that function relies on pandas. And so we're going to need to include pandas in our dependency list here. I would also recommend developing your project in a Python virtual environment that uses like the same Python version that you put here so that your dependencies can kind of line up properly. Okay, so now that we have that file all configured properly, we can just go ahead into our root again and run poetry build. And the result of that will be able to produce 2 files in a dist directory at, again, the root of your package. One of them is a zip file, and then we have a wheel file. Oops, click that a little fast. Okay, great. So we have inspected, we've analyzed, we've prepared our data. We have tested and modularized our preparation script, and we've packaged it all up. So now it's time to put this all into a pipeline. Okay, so first let's take a second and talk about what our pipeline will need to do. First, it will need to build our package because our script, again, needs our utility package to run. So if it doesn't build, we probably don't even need to bother with the tests just yet. But if it does build, we'll need to run our tests. This will validate that our package is good to go. Then we'll push our prepare script and our utility wheel to S3, where our AWS Glue job can pick those things up in order to actually do our data preparation. Okay. So we're going to be running this pipeline in GitHub. 2 minutes left. Wait, I started at 10:10. So that's 28. Okay. We're backing it through that. Okay. So we'll first take a look at dependent workflows and then we'll take a look at reusable workflows. So first, I'm going to explain some of the basics about GitHub workflows before we get too deep into them. In case anyone hasn't worked with them extensively. Workflows are configured with YAML files, and a simple workflow configuration will look something like what you see here. This workflow is named test. It will run on pull requests, and the simple way to explain that is that if you open a pull request from a branch against main, it'll run on the merge of the branch and main together. So it'll like run tests on the result of that merge. GitHub workflows or actions run on GitHub machines. So you'll see here that we declare the jobs that we want to run this workflow, to run. We'll tell it to use the latest Ubuntu distribution of Linux as the operating system, and then these uses tabs are just scripts that will set up that machine for us. And then we also will have to run the last 2 commands at the bottom, which will install our dependencies and then actually run PyTest. If PyTest returns a non-zero exit code, this workflow will fail and GitHub will let us know. Okay, so that's one small workflow. But just like we mentioned, we want our workflow to not just do one thing, but we want it to do 3 things. Ultimately, we will have a workflow that looks sort of like this. We'll build. If build passes, we will test. If test passes, we will upload. Okay, so this is a little small, but we are going to look at dependent workflows. So this can be achieved by using this needs tag, which is getting pointed to here. You can see here that we've chained these steps together. So our publish step needs the test step to pass before it will run. Test is declared right before it, and the test step needs the build step to pass before it will run. And that's how that looks. So this is fine, but the pipeline that we have here would likely only run on pushes to main, even though I know it has pull requests up there, but that was for testing. If we open a PR to change our utility module, we want the first 2 steps to run on PRs most likely, but not the third. And so in order to achieve that, we would have to have separate triggers for those two things. We would basically copy and paste those first two steps into another file. That would be run on pull requests, and then this whole file would be run on merges to main. But just like it was good to modularize our script to make certain pieces reusable, it would be great if we could have GitHub workflows that are modular and reusable to avoid the problems that come with copy and pasting. And it turns out that the wonderful people at GitHub have thought of this, and we can break each piece into its own YAML file. So this is our build YAML file, and the one thing I want to call out here is that on tag. On workflow call will allow this action to be called from another action, invoked by another action. So this is the first example where we see it. We can see the test. This is our test YAML. We can see that we have a build step, but instead of copy and pasting the code from the zip file we just saw, we just give it the file path to that build utils YAML. We still have our needs tag, and then that uses tag will pull in the other file. So now the tests depend on successful completion of the build step, and the build step doesn't have to be copy pasted. And then our prepare script will work similarly. We have the needs test pulls in the test YAML that we reference, and so all these three steps will get changed together. Okay, so this is what it will look like when it's running in GitHub. You see that in that top picture that the two steps on the right are just kind of waiting for the build step before they start. One picture down, the first two steps have passed, so upload go ahead and tries to upload our files to S3. If everything works, everything's passing, you get all green. And then in the bottom one, if something were to fail, the steps that depend on it are marked as skipped. So here our tests fail, so upload is skipped. We don't upload. Okay, so we've done a lot and we almost have all the pieces in place. The last thing I want to make sure we cover is creating our AWS Glue job. This Glue job will run our preparation script either on demand or on like whatever schedule we choose. Okay, so what resources does our Glue job need? It'll need our input data, our preparation script, and then it'll need our modules. Those will all need to be in S3 in our case. This was done either by our deployment pipeline or will be done with separate scripts. So if you're pulling in data from somewhere, you could have a script that just gets the raw data into the right spot. Okay, so we're gonna be looking at the Terraform that will build our Glue job. You guys are probably familiar with Terraform, but if you're not, it's just an infrastructure code tool that lets you build, change, and version infrastructure safely. And with Terraform, we can configure our S3 buckets and AWS Glue job in code so we can provision our resources in a way that's repeatable, and you can capture any updates or changes you need to make in version control, which is awesome. Okay, so this is what the Terraform will look specifically for the Glue job. The Terraform that if you see it on GitHub, it'll actually have a bunch of resources inside it. One of the really important ones will be the roles that we've configured to let our Glue job access S3. We're just not going to go into that right now. We're just going to focus on the Glue job itself. If you're familiar with AWS, you can see that this is just a way to create AWS resources with code. So instead of selecting drop-down options or filling in boxes, we just specify the key value pairs right here. Okay, so two things, again, that I want to point out, like if we zoom in on a couple spots, we're specifying the location of the script that our Glue job will use. That's in that script location value. And then we're also specifying the Python version that I mentioned when we were talking about our poetry package. Go over. Okay, so this is also really important. So default argument section, we have a couple of very important things. The temp directory we'll use to write temporary files during our script execution. This extra PyFiles argument will actually be the key to allow our script to run at all. This is where we'll put our wheel file that was created when we packaged our modules. Our prepare script relies on this package and won't run without this argument set properly. Also causing me a lot of pain, very important argument. Then the library set is pretty cool. That analytics library has there's a full list of what it pulls in on the AWS documentation, but it pulls in things like Panda, and then specifically the one we use is that library that we use to interact with S3. Okay, so then once we apply that, we'll have our glue job in AWS, and we can run it up in AWS with a script or just the button or whatever you guys want to do. Okay, so we did it. So just to go over all the things we did, and it was a lot, we did our data preparation, we extracted and modularized our prepare script, we packaged our new modules, we built our pipeline, and we created our glue job with Terraform so that it's ready to run. And that's all. So,
Thank you.